Hello everyone, welcome back. This is Engineer Hussein Mwasapi. So in this video, we'll be looking at the applications of alpha and beta roots. So before we begin, do not forget to like and subscribe. All right, so let's get to it. So I'll basically explain this concept with the help of a video. Be mindful, this is just like a first portion on alpha and beta applications. There's actually a lot to this. So I'll send more videos. So don't forget to hit the notification bell icon to stay updated with all the videos I post on these topics. All right, so we have an example that says that for the equation 2x squared minus 4x plus 5 being equal to 0, if alpha and beta are the roots, find this. So now be mindful that when we talk about roots, in simple terms, we're looking at the zeros, the point where the curve or the graph, when we say the curve, in simple terms, cuts the axis at a particular point. In this case, maybe the x, and in turn gives you zeros when you plug back. But anyway, you get to understand that when you try and learn how to graph these particular quadratic functions. So whenever you're solving this, you have to remember two conditions. So the first condition is that alpha plus beta is equal to negative b over a. Then the second condition is that alpha beta is equal to c over a. Then the other thing you should remember is the standard form of a quadratic equation. The standard form is ax squared plus bx plus c is equal to 0. Now the pluses could also be plus or minus, could also be plus or minus ax squared plus or minus bx plus or minus c, then equal to 0. The key is that I want you to understand that a, b, and c are what? Constants. They are literally just numbers. So you always have to mimic the standard form with the equation you've been given in question. So I've been given this equation in question. So basically, I want to understand how I can get my conditions from the equation being married with the standard form. So in math, whenever you have a fraction, or fractions rather, I'm having alpha over beta. To go about solving this, I'm having 1 over alpha plus 1 over beta. Be mindful that I'm having this equation, this fraction and the other fraction. So what I want to do is to express the two fractions into one single fraction by looking for the common denominator. So I draw a division line, and the common denominator between alpha and beta is literally the product of the two denominators. Alpha, beta. Then I'll say, what is alpha? What am I going to get when I say alpha into alpha beta? That would literally be beta. So beta times 1 is beta, then I maintain the sign plus. Then beta into alpha beta is alpha times 1, you get alpha. So now beta plus alpha is commutative. This means that I can also write my numerator as alpha plus beta over alpha beta. Now, why did I do that? It's because I want to satisfy my conditions. I want to end up having something that is similar to the conditions I'm having in question. So now, with the conditions I have, I can satisfy condition number 1 because it's alpha plus beta being equal to minus b over a. So I can evaluate this. Now, having the parent equation I'm having here, because this is the equation we're going to be working with, let me find what alpha plus beta is. Okay, so I know that with this equation, the value of a is 2, the value of b is negative 4, and the value of c is 5. So for substituting for b, I'll put the value of b, which is negative 4, over the value of a, which is 2. Then alpha plus beta will be equal to negative times negative is positive, so I get 4 over 2, and 2 into 4, that basically gives me a 2, like that. Then I can also solve condition 2, which is me finding alpha beta. Now alpha beta is equal to c over a. So alpha beta is equal to the value of c, which is 5, over the value of a, which is 2. So I basically get a 5 over 2. So these values I can substitute with my computation. I'm having my numerator to be alpha plus beta, so I'll substitute for the value of alpha plus beta, which is here. Alpha plus beta is basically 2, so I'll say 2 over alpha beta, which is 5 over 2. Now, I'm having 2 divided by 5 over 2. So I can write this in a sensible way, where I say 2 over 1, then division turns into multiplication, then this reciprocates into 2 over 5. Now multiplication is direct, so I'll say 2 times 2, that is 4 over 5. And that's the answer. So if you want, you can say therefore 1 over alpha plus 1 over beta is equal to 4 over 5. And that's how you go about solving this question, which is A. So now, let us now try and solve another type of question. Now, we're going to stick to the same parent equation. Now, be mindful that the parent equation that we have is 2x squared minus 4x plus 5 being equal to what? 0. And the condition that we have is the first condition, alpha plus beta is equal to what? Yes, minus b over a. Then condition 2 is alpha beta being equal to c over a. Now, b of the same particular question is where they would ask us to say find alpha plus 1 and beta plus 1. Now, to go about solving this, whenever you see parentheses in math, all you're supposed to do is to expand. So to expand this, I'll get the first element in the first parenthesis, which is alpha, and multiply it with the entire second bracket, which is beta plus 1. And I get the second element in the first parenthesis, which is plus 1, and multiply by the entire parenthesis of the second brackets, which is beta plus 1. Now, if I multiply alpha times beta, I get alpha beta. Then if I multiply alpha times 1, then I get alpha, then 1 times beta, I get beta. 1 times 1 is basically 1. So now, if you look at this clearly, remember, we did find that these conditions, just wanted to help you remember something. We found that alpha plus beta from this, remember, because we're saying it's minus b over a, so it's going to be like minus 4 over 2, which would literally give us like 2 in the end. Then we found alpha beta to give us what? 5 over what? 2. So now I'm trying to look at how I can get alpha plus beta from this and how I can get alpha beta. Now, if I want, I can put alpha beta in brackets. Then I can look at the alpha plus beta I'm having, which is this guy here. Then the plus 1 remains as a number. So alpha beta is literally 5 over 2 plus alpha plus beta, which is me substituting and putting what? 2, then plus 1. Now, this means I'm having 5 over 2 plus, now this 2 can say 2 over 1, because now all I want to do is to have a single fraction because I'm having multiple fractions. So I'll say over 2. Now 2 into 2 is 1 times 5, that is 5. 1 into 2, I'll maintain the sign plus. 1 into 2 is 2 times 2, it's 4, maintain the sign plus. 1 into 2 is 2 times 1, that will basically give me 2. So this means that 4 plus 5 is 9, plus 2 is 11 over what? 2. So I'm having that as my answer. So if I want, I can say therefore alpha plus 1 times beta plus 1 is basically equivalent to 11 over 2. And that's how you go about solving such a question. So now, other questions could be where we might be asked to find a different scenario where maybe we don't have the case we have at the moment. So let me give you a different condition now. Now, using the same parent equation. Now, remember the parent equation is the same. We're having the same parent equation. So let's not get lost. So the parent equation, remember, is this guy. So the parent equation is 2x squared minus 4x plus 5 is equal to 0. Remember, the conditions have been evaluated already. The conditions is 1, alpha plus beta being equal to what? 2. Then condition 2, alpha beta is equal to 5 over 2. I hope everybody knows how to now get alpha plus beta and alpha beta. Remember, alpha plus beta is minus b over a. Then alpha beta is literally c over a. So now imagine if I gave you a condition like C where I want you to find alpha squared plus beta squared. Now to go about solving this, every time they ask you such a question, even if I said find, okay, let me be precise. If they told you to say find, let's say alpha to the n plus beta to the n, all you have to do is to rewrite this as alpha plus beta, then raise it to the n, and then expand this to get a value this side. Whatever value you get this side, try and get something that looks like this and mimic the equation. Now, what I'm trying to say is this. Here I'm having alpha squared plus beta squared, so the n's are the 2. So this means that this will be written as alpha plus beta to the power n, which is 2. And then what I have to do is to expand it. So I'm going to expand it on a data side. So I'm going to say data and put the data this side. When I expand alpha plus beta squared, alpha plus beta squared is the same as alpha plus beta times alpha plus what? Beta. So now I want to find the value of this. So I'm going to multiply, I'm going to expand this here. I'm going to get alpha and multiply it by alpha plus beta. Then I'll get the second element, which is plus beta, multiplied by alpha plus what? Beta. Then alpha times alpha will give me alpha what? Squared. Alpha times beta will give me what? Plus alpha beta. Then beta times alpha will give me plus alpha beta. Then beta times beta give me beta squared. Now alpha beta, so I'm having alpha squared. So alpha beta plus alpha beta, these are like them. So you get a plus 2 alpha beta plus beta squared. So now this is what you get when you expand your alpha plus beta squared. So now this means that alpha plus beta squared is equivalent to alpha squared plus 2 alpha beta plus beta squared. So now having that, I want to get something that looks like this, like the question I'm having. So I'm having alpha plus beta squared, so I can put alpha squared plus beta squared like that, then say plus 2 alpha beta. So now for me to get this condition here that I'm having in my question, I can take the plus 2 alpha beta to the other side of the equation, and I'll have alpha plus beta squared, then minus 2 alpha beta being equal to alpha squared plus what? Beta squared. Now remember, in mathematics you can flip the equation. Now this entirely means that alpha squared plus beta squared is equal to alpha plus beta squared minus 2 alpha what? Beta. Once you have this, it means that you can solve, because now I have the question that I need to find, which is alpha squared plus beta what? Squared. So now I know that my alpha squared plus beta squared now gives me the conditions I'm having, which is alpha plus beta and alpha beta. So alpha squared plus beta squared is equal to the value of alpha plus beta, which is 2. So I'll put 2 there, square it, then minus 2 times alpha times beta, which is 5 over 2. Then alpha squared plus beta squared is equal to 2 raised to 2, that's 4. Then I know you can reduce by saying 2 there, 1, 2 there, 1, then you remain with a 5, but for the sake of the explanation, I'll say 2 times 5 rather will give me what? Minus 10 over 2. Then alpha squared plus beta squared is equal to 4 minus 2 times 10 is what? 5. Then alpha squared plus beta squared is equal to 4 minus 5, which is basically a minus 1. So minus 1 is the answer of alpha squared plus beta squared. So remember, even if I gave you like alpha to the power 3 plus beta to the power 3, the entire goal is just literally to expand and try and get something that looks similar with what the question is trying to say. So for the sake of explanation, I'll try and go through the cubed part. So remember, we're still looking at the parent 2x squared minus 4x plus 5 being equal to 0. Remember the conditions we have. Conditions we have is that alpha plus beta is equal to what? Negative b over a, which gave us 2. Then we have condition 2, alpha beta is equal to c over a, which gave us 5 over 2. Now imagine now that we have been asked to it should be d, forgetting letters. Now imagine if we've been asked to find alpha cubed plus beta cubed. So all I'm supposed to do is now raise the n outside the parentheses. So I'm going to say alpha plus beta cubed. Now we know this is equal to, we're trying to repeatedly multiply the expression of the parentheses 3 times. So having alpha plus beta times alpha plus beta times alpha plus what? Beta. Now for those who know binomial expansion, you can always do your binomial and you get your answer. And that's the easiest way you can actually do it. So I can actually expand this by the side. So I can call this data. So let me just fast forward a little bit. So you know if we have alpha plus beta, this is like alpha plus beta times alpha plus beta. So I'll first multiply the first two. So I'll do this guy and that guy. So alpha plus beta times alpha plus what? Beta. So remember, we're going to multiply alpha times alpha, that's alpha squared. Alpha times beta, that's going to be plus alpha beta. Then beta times alpha, you know, beta times alpha, no, you're going to say beta alpha, but beta alpha is the same as alpha beta, associative. So alpha beta, then beta times beta is beta squared. So beta squared. So alpha squared, then plus, these are like terms, literally like terms, guys. Like terms are enough, but enough. So we're going to have plus 2 alpha beta plus what? Beta squared. So now you have expanded the first two parentheses. So now I have to expand this guy with the second guy. So I want now, so it's called this data 1. Let me call the second one data 2. So I want alpha plus beta to expand with alpha squared plus 2 alpha beta plus beta squared. I hope you're following. Alright, so now to expand this, I'm going to multiply the first alpha times alpha squared plus 2 alpha beta plus beta squared. Then the plus beta will multiply everything as well. After that, then 2 alpha beta, then beta squared. So beta squared. Then also the alpha times alpha squared is alpha cubed. Then alpha times 2 alpha beta, that is 2 alpha squared beta. Then alpha times beta squared is plus alpha beta squared. Then beta times alpha squared is alpha squared beta. Then beta times 2 alpha beta is plus 2 alpha beta squared. Then beta times beta squared is beta cubed. Alright, so we have beta cubed it. So now I'm trying to look for this guy here. So I can put those guys as the first thing. So I can say alpha, before I do that, let me take that back. So alpha cubed plus beta cubed. So I can look for something that is common here. What two terms are common? So I'm having 2 alpha squared beta and alpha squared beta. So I'm having plus 3 alpha squared beta. Then I'm also having this guy and that guy, which also give me plus 3 alpha. This should be beta squared. So this means that I found what I needed here. It's not the final answer though. It's just an expansion. So it means that alpha plus beta cubed is equal to alpha cubed plus beta cubed plus 3 alpha squared beta plus 3 alpha beta squared. So basically I want to end up having this guy as the only thing on one side of the equation. So I'll take all these bad boys the other side, and I'll have alpha plus beta cubed being equal, no. When these guys come this side, they to be minus alpha squared beta, then minus 3 alpha beta squared is equal to alpha cubed plus beta cubed. So this means that alpha cubed plus beta cubed is equal to alpha plus beta cubed minus 3 alpha squared beta minus 3 alpha beta squared. Now alpha cubed plus beta cubed is equal to alpha plus beta cubed. So I only have one condition, which is alpha plus beta. But now what of this side? So I can factor out the common values here. So what am I having in common? I'm having a minus, even a 3, even alpha, even beta is common. So if I pull out minus 3 alpha and beta, I'll just remain with alpha. And if I pull out minus 3 alpha beta in minus 3 alpha beta squared, I'll just remain with plus beta, like that. I hope no one is confused at this point. It could be a lot of work. I know at first glance this might look like a handful, but if you keep on watching this video over and over again, you get the hang of it. You get to understand it. Yes. So mostly, I know at this point, some of you might be lost, but be mindful. All I did was that once I expanded this, I had to equate. Remember, we said this guy is equal to this, because whenever you have a base raised to a power, let's say n, it's all about the number of times the base is repeatedly multiplied by itself. So I expanded the first two entities, or these guys, and I got my expansion. So I said my expansion, which is put here, is equal to whatever I got after expanding. And then the key was to have something that looks like this. So from whatever I expanded, I wanted to have something that looks like this. And something that looks like this is here. So what I had to do was that now that I have that, everything that has nothing to do with my question has to go elsewhere. So I took this entire family and threw it the other side of the equation, so that I can just end up having this guy on one side of the equation. Now, remember, this is an equal sign, so I'm having one side and the other side. So I'm having now my question on one side. So now what does my question equal to? I can flip this because most of us are used to seeing this guy as the first thing, and it's equal to that. Now, the goal was to understand that I'm having this one here, which is alpha beta, which is one of the conditions, but I don't know what this guy is, so I had to factorize. I had to factor out 3 alpha and beta. So I also put out the negative because my other condition is alpha plus beta, you see. Then I can pull out and end up having alpha beta. So when I put out the 3 and the alpha beta, I end up having minus 3 alpha beta outside. Then I was multiplying by alpha plus what? Beta, like that. So this means that even if I took, because factorizing is the opposite of expanding, you get the point. So it means that minus 3 alpha beta, if I multiply it by alpha, I have to get this guy. And even if I multiply minus 3 alpha beta times beta, I have to get minus 3 alpha beta what? Squared. Now I reach this point, all I have to do is to plug back with my conditions. Alpha cubed plus beta cubed is equal to alpha plus beta, which is 2 cubed, minus 3 alpha beta, which is 5 over 2, then times alpha plus beta, which is 2. So alpha cubed plus beta cubed is equal to 2 to the power 3 is 2 times 2 times 2, which is 8. Then minus 3, remember the scalar only affects the numerator, so it's going to be minus 15 over 2. Then I'm having times 2. So alpha cubed plus beta cubed is equal to 8. Then the 15 multiplies the 2 and you get a minus 30 over 2. So alpha cubed plus beta cubed is equal to 8 minus 2 into 30 is 15. So alpha cubed plus beta cubed is equal to 8 minus 15. 8 minus 15, yes. So the answer will be 7 minus what? 7. So I knew you guys knew the answer. Yeah, you guys are very good. So that's the answer that you get when you do alpha cubed plus beta cubed. So what I want you to do is the last question. This is going to be the last question. I know I've done so many questions. It's going to be the last question. So yeah, pay attention. Yeah, so the last question was saying it's a bonus, like literally a bonus question for you guys. We're still using the parent 2x squared minus 4x plus 5 being equal to 0. So imagine the bonus is alpha squared beta plus alpha beta squared. So all I have to do here is remember that the conditions I have is condition number 1, alpha plus beta giving me 2. Condition number 2, alpha beta giving me 5 over 2. So I know I can factorize this because this doesn't look nice. So alpha beta is equal to alpha plus what? Beta, just like that. You have found your answer. So alpha beta is 5 over 2 and alpha plus beta is 2. Then 5 times 2 is 10 over 2. 2 into 10, that's 5. And that's your final answer. Alright, thanks for watching. Remember, if you have queries, you can always reach me on WhatsApp on the line 077 149 5252. Remember, slow progress is better than no progress. And that's the guys before becoming a statistic. Let's try to put that a plus.